Good morning, scholars. I hope all is well with you and that you've had a great weekend. Today we are going to start the next topic in our, wrap up of quantitative literacy, that dealing with sequences and series. So today we're going to look at how to identify two types of sequences, an explicit and a recursive, and then how to evaluate an explicit and recursive sequence. To start off, however, we first need to identify what these sequences mean, what a sequence actually means. So, sequences are functions that represent a set of consecutive numbers that follow a specific pattern. They follow a specific pattern. Now, the values in these sequences are what are known as terms. They're what are known as terms. So, for example, if you have the numbers 2, 4, 6, 8, and 10, that's a sequence. They're all following a pattern. Each of them are going up by 2. The 2, the 4, the 6, the 8, and the 10 would be known as terms. So 2 would be called A1 because that's the first term in the sequence. 4 would be called A2 because it's the second term in the sequence. The 6 would be A3, and then so on for however many terms you have in the sequence. So another thing with a sequence is that it can be specified by an equation, which the equation we would call a rule. We would call that a rule. So as such, if you look at the two examples that we have our first example is just a set of numbers, 5, 8, 11, 14, and so on. Each term is being added by 3. Whereas the second example, you have 2n squared plus 1, that's an equation. It's still describing the pattern. Square, multiply times 2, and then take the result and add 1 to it. So both of these instances are examples of sequences. So now that we know what a sequence is, a mathematical sequence can fall into two different categories. The first such category is called an explicit sequence. With an explicit sequence, it follows a defined pattern throughout the entire problem, whether it's adding, subtracting, multiplying, dividing, or some combination of them. Now, if you remember earlier this year, we studied an arithmetic and a geometric sequence. Arithmetic sequences, adding and subtracting, geometric sequences, multiplying and dividing. Those are examples of explicit sequences. Explicit, it comes just off of a direct equation. The second type is called a recursive sequence. A recursive sequence is a sequence in which each term follows a particular pattern and uses the answer or answers that came before it. So notice that in examples 1 and 2, they're giving you numbers to start with, and then they give you the rule, the pattern that they want you to follow. So that's what makes a recursive sequence recursive. You're going to be given something to use, but you're also going to be using those answers to solve them out. So there's a little bit of terminology that you need to know using a recursive sequence. So AN is basically whatever term that you have, whatever term you want to get. AN minus 1, however, is the term that came before it. AN minus 2 is the term that came before that. So the n represents a particular number. So let's say that you had that n is equal to 3. So AN would be A3, third term. AN minus 1 would be A3 minus 1, which is A2. So the second term in the sequence. a n minus 2 would be a 3 minus 2, a1. So a1 is the first term in the sequence. So it's not harder, it's just a little bit more that you have to pay attention to. But that's how a recursive sequence works. So we've gone through the basic setup, we've gone through the types of sequences. So now we're going to take an opportunity and look at how to actually evaluate a explicit and recursive sequence, which if you can evaluate an expression, you can evaluate a sequence. So let's start with an explicit sequence. Let's start with an explicit sequence. So with an explicit sequence, it's pretty simple to do. All we actually need to do in this case is take the number, plug it in, and work the problem out. Take the problem out, take the number, plug it in. So for example 1, we have a sub 1 equals a sub n equals 6 plus 3n, and we're being asked to find a1 and a15. So we're being asked to find a1 and a15 in this case. So finding those is not difficult. For a1, you're going to take 1 and plug it in for n. And then you're just following order of operations. 3 times 1 is 3. 6 plus 3 is 9. And that's it. That's all. A15 would work the exact same way. 6 plus 3 times 15. 3 times 15 is 45. And you get 51. So there's your 2 answers for example 1. So, go on to example 2. Example 2, 5 times 4 raised to the n minus 1 power. You're looking for a1 and a6. Same rules apply. Find a1, take 1, plug it into the problem. So 1 minus 1 is 0. Remember, you still have to follow order of operations. So 4 to the 0 power is 1. And 5 times 1 is 5. Then to get a6, you're doing the exact same thing. So 6 minus 1 gives you 5. So 5 times 4 to the 5th power. So please, please, please make sure you follow the order of operations. You're doing 4 to the 5th next. So 4 to the 5th power is 1024, which gives you an answer of 5120. So again, it's important that you do follow the order of operations. And then one more example of explicit. You've got 2n squared plus 3n minus 4. So again, a1, 2 times 1 squared plus 3 times 1 minus 4. Of course, in this case, once you have it set up, then I don't mind if you let the calculator do the rest of the work. So if you work that out, you should get 1. Again, making sure you follow the order of operations correctly. And A9, exact same thing. 2 times 9 squared plus 3 times 9 minus 4. Again, once you set it up, let the calculator do the rest of the work, and you end up with 185. So, when you're evaluating an explicit sequence, you're literally plugging numbers in, and that's it. When you're working with a recursive sequence, then it changes a little bit. When you're working with a recursive sequence, then it changes a little bit. So to evaluate a recursive sequence, you start with your given value and you follow the rule to get your next answer. Then you use the next answer to continue the sequence. So you're going to start with something. The rule is going to tell you what to do with it. And then you find the rest of your values. So let's look at example 4. Example 4, you have that A1 is equal to 7. So that's what they're starting you with. AN equals 5 plus 2 times AN minus 1. So that's telling you the rule. And then you have to find the next 3 terms. So you're trying to find what is A2, what is A3, and what is A4. So remember, AN minus 1 is the term that came before it. That's going to be something important for you to know. So A1 is 7. That was given to us, so we're good. So A2, that means n is equal to 2. That equals 5 plus 2 times n minus 1. If n is equal to 2, then 2 minus 1 is 1. So 2 times A1. Key thing here is you already know what A1 is. It was given to you already. So this actually solves itself out as 5 plus 2 times 7, which if you solve that out, gives you 19. So A2 is equal to 19. So that means when you find A3, you're not going to use the 7 anymore. You're going to use 19 to solve the problem. So that's 5 plus 2 times 3 minus 1 is 2, so you're using the A2 term. A2 you just found. That was 19. So that's 5 plus 2 times 19. 2 times 19 is 38. 38 plus 5, 43. So that now we have A4. So A4, 5 plus 2 times 4 minus 1 is A3. So we already know what A3 is equal to. A3 was 43. So that's 5 plus 2 times 43. 2 times 43 is 86. 86 plus 5 is 91. So there's your next 3 terms. 19, 43, and 91. So notice with a recursive sequence, you use the numbers that came before it to help you solve the problem. Use numbers that came before it to help you solve the problem. So it may look a little weird at first, but take your time and you'll get it all figured out. So let's do another example. So another example, we have a1 equals negative 3, a2 equals 4, and then we have our rule, an equals an minus 1 plus an minus 2. So that means you're using the next two terms behind it to solve it out. So let's start solving. So we need to find a3, a4, and a5. So a1 is negative 3 and a2 is 4. So to find a3, so n is equal to 3. So it's a3 minus 1 plus a3 minus 2. 3 minus 1 is 2. And we already know what a2 is. They gave it to us. So you plug it in, you get 4. Plus 3 minus 2 is 1. And a1 was already given to you. Negative 3. 4 plus negative 3 is 1. So that's your first answer. So a little bit more explanation involved there. So hopefully it helps us with the rest of it. So a4. So to do a4, you're using the two terms that came after it. So 4 minus 1 would be a3, plus 4 minus 2 is a2. So notice in that time, instead of working it out, I just did it in my head, but I'm showing on the paper what I'm actually going to do. So I'm still showing my work. A3 was a term that you just found, that's 1. A2 was one of the numbers that was given to you, so that's 4. And then 1 plus 4, 5. So now we have two of our answers. So last one, a5. So 5 is the end value. 5 minus 1 is 4. 5 minus 2 is 3. So a4 was the answer you just got, which is 5. a3 is the answer that you got before it, which is 1. 5 plus 1 gives you 6. There you have it. You have 1, 5, and 6. And all you're doing is using the numbers that came before it. So, last example for this lesson today is example 6. You've got 2, you're starting with 2 and 7, and your rule is an minus 1 squared minus an minus 2. So, important thing is just to pay attention to the pattern and to pay attention to what you should be doing. So, let's go ahead and knock this one out. So, a1 is 2, a2 is 7, so a3 would be an minus 1, so 3 minus 1 is 2, so a2 squared minus 3 minus 2 is 1, minus a1. So a2 we already know. It was 7. So that's 7 squared minus 2. So 7 squared is 49. 49 minus 2 is 47. 49 minus 2 is 47. So let's go to a4. So n is equal to 4 in this case. So 4 minus 1 is 3. So a3 raised to the second power minus a n minus 2. 4 minus 2 is 2. So A3, we already figured out what that was. That was 47. So 47 squared minus 7. I can tell this one's going to come out to be a big number. 2,202. Which means A5 is going to be humongous. 5 minus 1 is 4, so you have A4 raised to the second power minus 5 minus 2 is 3, A3. So we plug in what we have, 2,202 squared minus 47. Then we let the calculator do the rest of the work. But you get this nice gigantic number of 4,848,757. So don't get all weirded out over the fact that it's a big, humongous number. The important thing to keep in mind is as long as you're following the sequence correctly, then you'll be in good shape. But with that, that will complete the audio lesson for this particular section. Remember, what we did was looked at how to classify between a explicit and a recursive sequence. And we also looked at how to evaluate each of those type of sequences. So the assignments that will be posted for you today, 2 of them will be IXL assignments for you to attempt and to practice. And 1 of them will be a Google mini quiz for you to complete. So with that being said, I hope you have a great rest of your day, and I'll talk to you soon.